guys, we're going to start with factors and prime numbers. So we're going to start with this vocabulary lesson that you've seen before, and you know what? I'm just going to let it play right here and let you all listen to it real quick because today's daily math has some factors.
Yeah. Vocabulary. Oh yeah, factors too. F-A-C-T-O-R-S with the factors. We go into a bigger number evenly. Yeah, don't get it backwards. F-A-C-T-O-R-S with the factors. We go into a bigger number evenly. Yeah, don't get it backwards. Factors go into a bigger number evenly with nothing left over, believe in me. Memorize your times table like an actor. All numbers have one as a factor, cause all numbers can be divided by one with no remainder. That's how it's done. If you have a number and you need to know all its factors, just start the show. We figure out our factors by closing the curtain. Let's try 32, see how it's working. The first combo we can multiply to get 32. It's 1 and 32, like the one on the left, 32 over there. Now we try 2 to find the next pair. 2 goes into 32 16 times, so we write the 16 on the right hand side. Next up is 3. Well, let's see, does 3 go into 32? Not evenly, so it's not a factor. But what about 4? That goes in 8 times, yeah, for sure. 5, 6, and 7, they don't go. And now you can see that the curtain is closed. That's all the factors for 32 for sure. Now hit the spotlight for the next show. If a number only has 2 factors, itself and the number 1, then the fact is we call that number prime. Like Optimus Prime, they're one of a kind. 3 is prime, so a 5 is 7. 9's not prime, but there's prime at 11. 101, that's certainly prime, so it's 3,559. F-A-C-T-O-R-S with the factors. We go into a bigger number evenly. Yeah, don't get it backwards. F-A-C-T-O-R-S with the factors. We go into a bigger number evenly. Yeah, don't get it backwards.
Alright, that was fun. Alright, we're going to switch over to the ladybug now. Let's put this down. There we go. Okay, so we're going to start with subtracting. All right, so 2,535 minus 2,172. 5 minus 2, I can do that. 5 minus 2 is 3. 3 minus 7, I cannot do that. 7 is larger than 3, so I cannot subtract. I need to go next door, and I need to regroup. So that 5 is now going to be a 4. I'm going to move 1 100 over to my tens place. And when I move that 1 100 over to my tens place, it gives me 10 tens. So now I have 13 in my tens place. 13 minus 7 is 6. 4 minus 1 is 3. 2 minus 2 is 0. So my answer is 363. Okay, we're going to write our fact families over here. 5 times 3 is 15. And then we have 3 times 5 that we could do, which would be the opposite. That's the commutative property. We just switch those numbers. They can change sides and you still get the same answer. Okay, and then the other part of that fact family is going to be our division. 15 divided by 3 is 5, and 15 divided by 5 is 3. Now, for this multiplication question on your exit ticket, it's going to ask you what is the other multiplication fact. So you're going to want to pick the multiplication fact. 3 times 5 is 15, because that's what it's asking for. But just know that those are also 15 divided by 3 is 5, and 15 divided by 5 is 3 are also part of that fact family. Okay, and then here we have 30 times 2. When we multiply 30 times 2, we're just going to look at the front digits, okay, to start. 30 is a multiple of 10. So I can use my same strategy. When I multiply by 10, I put a 0 on the end. So 3 times 2 is 6, and then we can move this 0 to the end to make 60. Now let me bring you down here and show this to you in place value form. So we have ones, tens, hundreds, okay? And if I have 30 in my tens, that just looks like 3 in the tens place, right? That's 30. And if I do that 2 times, do you see how that just looks like 3 times 2 right there? The only difference is it's 3 times 2 in the tens place, not in the ones place. So that's why I can just say that that's 6. I'm multiplying the 3 times 2. It's in the tens place because there's 1 0 there. So it's 60 on the end. Okay, that kind of gives you a visual about why that trick works. 30 times 3. Okay, so if I do 30 times 3, I'm just going to focus on the front digit. 3 times 3 is 9. Then I'm going to put the 0 on the end. Okay, now this one works just the same. Let's do this again. Ones, tens, hundreds. I've got 3 in the tens place. And this time I've got 3 times 3, or 30 times 3, because that's 30, and that's 30, and that's 30. So I've got 33 times. So 3 times 3 is 9, and that's a 9, but that 9 is in the tens place. So I need to put that 0 on the end. 3 times 4, we're just going to do this one like this. 3 times 4. Okay, this one's a little bit more tricky. Okay, I'm going to come over here. Ones, tens, hundreds. Okay, so I've got 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Now, when I do 3 times 4, that gives me 12. Uh-oh, 12 is too big to fit in the tens place. I need to regroup this 10 over to my hundreds place. So now I'm going to take 10 of these and I'm going to move them over to the hundreds place. So that 1 needs to come over here to the hundreds place. Does that make sense? Okay, so I'm going to have 12 here. Still 12 with the 0 on the end. But when we say that, we don't say 12 tens. It is 12 tens, but we say that as 120. Okay? All right, factors of 11. So for 11, I can do 1 and 11. Now let me think. Can I do 2 times anything to get 11? No. 3 times anything? No. 3 times 4 is 12. No. 4 times anything? No. 5 times anything? No. 6? No. 7? No. 8, 9, 10, 11. The only way I can get 11 is to do 1 times 11. So this 11 is an example of a prime number. It's prime because I can only multiply by 1 and 11. Thanks, guys. This is the last day of our week 4 daily math, and I will see you next week.